Welcome to the On-Premise IT podcast, the only show that dares to be both on topic or on premise, and sometimes even on location or on premises. Each time we meet, we bring together a group of IT experts to discuss a single premise or idea. On today's episode, which is presented by Pure Storage, we are going to be discussing the disruptive effect of AI infrastructure on enterprise technology. Is it even compatible with conventional IT systems? Well, we'll see. But before we get into that premise, let's discuss who's on the podcast today.
Hi, my name is Justin Emerson. I'm a product manager here at Pure Storage.
I'm Allyson Klein. I'm a principal of the Tech Arena.
I'm Keith Townsend. I'm principal of the CTO Advisor.
And as I said, I'm Stephen Foskett from Gestalt IT. You recognize me from some of these podcasts. And you probably recognize our guests as well, because these are all people that have had a long history in enterprise technology, and all of us have seen this disruptive impact of some new applications. But AI is more disruptive than most. On 3 seasons of our Utilizing AI podcast, one of the things that became very, very clear is that this application requires incredible commitments of technology. It is very, very demanding, both in terms of performance, in terms of scalability, in terms of data sharing. And yet AI people aren't really ready for that. They don't really know much about storage, and they're not really wanting to know a lot about storage. And I think that's sort of where we want to go today. So first off, Justin, talk to me a little bit about what you've seen with your customers in terms of having them try to develop some kind of infrastructure for AI, and how's that worked out for them?
Well, it's been a problem ever since the beginning of when we saw enterprises start to adopt this. So back in 2018, Pure launched a reference architecture called AIRI, which was designed to sort of create the first reference architecture for AI infrastructure. And what we've seen is that more and more customers are looking for that kind of guidance. And the reason they would be looking for that kind of guidance is it's fundamentally different than the kinds of infrastructure that they would typically be deploying. And I think that's sort of one of the core things we're going to talk about today is that it is so different from traditional IT. It's more akin to the kind of infrastructure that you would have found in a high performance computing environment over the last couple of decades. And that's generally something that enterprises haven't even attempted to dabble in. And partly that's because it's not only bespoke infrastructure, which often is sort of counter to the strategy of most enterprise infrastructure, but also it's very specialized, it's very different, it requires a very different kind of skill set. And like most new technologies, the number of people with that skill set is extremely limited. So when we talk about how AI infrastructure is disruptive to enterprise IT, on many different axes that I'm sure we'll talk about, but I think the biggest one is that it's just so different, and customers are looking for help on how do I navigate this without completely breaking everything else that I've been building and accumulating over the last several decades of IT.
And to that point, one of the things that I've noticed in the HPC world, when we try to combine both HPC types of workloads and environments with the traditional data center, is that if you've operated a budget for any period of time, you're trying to sweat these assets as long as possible, 3, 5, 7 years. And HPC and AI moves much faster than the typical data center lifecycle. So what we would like to do is kind of demote our tier zero storage down to tier 1 storage and use these assets over and over again. This is specialized hardware. How do you demote a GPU down to general purpose compute when it's specifically designed to do AI work?
Now, that's not to say that HPC isn't present in the enterprise, because there are many substantiations of HPC configurations within enterprise environments, but it isn't necessarily something that flows with the mainstream of technology. And in fact, many enterprises treat that as a silo unto itself, and manages it just as Keith was saying, as a very different beast than traditional enterprise architecture. As we look at AI, are they able to scale that and actually integrate into the norm? I'm not sure.
I think on the point of, say, demoting GPUs or trying to leverage GPUs for other things, one of the trends that we sort of were expecting was more enterprise applications to start leveraging accelerators like, for example, GPUs. I remember, more than 5 years ago, seeing a lot of experimentation in GPU accelerated databases or other what would typically be enterprise applications. But we haven't really seen that adopted en masse in the enterprise. And really, it seems like the only key bastion for these kind of accelerators, GPUs in particular, seems to be in this sort of AI space.
Yeah, and then couple that with the second level challenge, or for some people, the first level challenge. Our environments are not designed for these heavy workloads. A typical rack in a Equinix QTS, digital realty type of colo, or even the traditional enterprise colo, these racks are getting in 5 to 10K of power per rack. That can be one server in a AI implementation. So now you're looking at anywhere from upwards to 45K or 100K of power coming into a single rack. And then we have to figure out cooling, which is more than likely going to be liquid based cooling. And the ideal of putting any kind of liquid in a data center is just in the enterprise data center. I don't even want to think about it.
You just talked about tiers of GPUs, Keith, and now you're introducing liquid cooling. It's getting real on the podcast today. I think that's a really good point. We're talking about a different level of sophistication with infrastructure holistically. And storage just fits into that, right? What are you going to do to satisfy the demand for all of this data? And, I think that my gut says that some enterprises will dabble in this space, but the cloud exists for a reason. And we've seen enterprises tap cloud for those more sophisticated use cases. I don't see that we wouldn't get to, for a lot of enterprise customers, a similar conclusion of, I'll just take advantage of fantastic services offered by my cloud service provider of choice.
And I think if you're going to leverage cloud services for this kind of stuff, one of the things, we're talking about power, we're talking about the scope of your own data center, moving that somewhere else starts to mask some of the environmental challenges that this creates, right? So when we talk about ESG, as Stephen points out, we're talking about the E in ESG here. Having all of these very, very high power systems that not only, as Keith mentioned, take up a lot of real estate due to sort of the reality of how we design racks. But it also is going to be very challenging for companies who have their own ESG goals that they're trying to meet to do this at the same time.
Yeah, and thanks for bringing that up, Justin. That's a huge thing for me. I keep hearing companies talk about ESG. They're really talking about environmental and sustainability goals for the most part. And that's a really, really important consideration, especially for enterprise data center. As anyone who's deployed technology in Europe, especially, will tell you, power and cooling is a huge issue, and efficiency, overall data center efficiency, is absolutely critical. And it's becoming more critical here in the US as well. I think for a long time, there's been this assumption, especially from Europeans, that power is infinite and unlimited, and so is space over here. That's not the case as much anymore. I think that people are starting to think more about power, mainly from a power balancing perspective. In other words, how much power can I really have per rack? How much, how can I impact that? And these are some power hungry systems. We were seeing, kilowatt servers. That's a problem, and it needs a solution. One of the things, Justin, you brought up previously in briefings is the sort of balance between storage system power and accelerated processing power. And this is a way to maybe address that concern. also having external storage systems is important when you're considering balancing power per rack, because it means that the system, the storage system can be in a separate rack from the processing, which is another thing. So I guess, Allyson, you have a lot of visibility into this sort of where the data center processors are going, where the data center architecture is going, and this concern. What do you think?
It's interesting. I'm in the middle of a compute sustainability study at the tech arena, and data centers are taking 3% of the world's power. So that doesn't seem like a lot, but it's like more than the airline industry, right? You got to put it in perspective. And a lot of these brownfield data centers were not designed to deliver power to the rack that GPUs, which are not power sipping devices by any stretch of the imagination, are demanding for these large AI clusters. So it really does lend us to, how do we get the power envelope that's required in this rush to AI? And to me, it's biased towards those folks who can build some greenfield data center space, um, or really limits the amount of compute density that can be achieved with GPU clusters. So I think we've got a lot of questions, and one thing that I think about, Stephen, as we move forward with so much constraint in GPUs, so much focus on build out of GPU clusters, is does that open the door for alternative architectures? We know that AI inference performs very well on CPU architectures. There are a number of um, alternatives out there, a lot of startups that are creating alternative architectures for AI. I think we're really at a moment where we're going to see a lot of innovation in infrastructure just because the customer is demanding it.
To that point, Allyson, we saw one of our largest AI customers. They were only able to deploy in a brownfield data center 2 GPU servers per rack. Two-thirds of that rack was empty, and that's just sort of the reality of repurposing old data centers designed for maybe 10 or 15 kilowatts per rack into these really, really massive accelerators.
So I'm sensing a theme here, which is data centers that most of us are used to managing, building, maintaining are centered around general purpose compute, this ability to put any application on. And Stephen, I got to ask you the question: Are we thinking about accelerators and GPUs wrong?
Absolutely, I think that is a perfect consideration here, because um, I think a lot of people are still so CPU focused when they're talking about enterprise data center, and yet we have an embarrassment of CPU cores now. I think more and more processing is limited by memory and by specialist accelerator, and sort of overall data center configuration in enterprise tech. And I really think that we're on the verge of I don't want to say a revolution in system architecture. I mean, it could be, or it could just be a big evolution in system architecture in which accelerator-based computing becomes more and more important. And that is certainly the message that we've gotten from Intel. It's also the message we're hearing from NVIDIA, from AMD. Uh, and the idea is, yes, CPUs are incredibly important, but we're going to have an architecture that's going to incorporate a variety of other kinds of accelerators. And that could be GPUs, which we've been talking about with machine learning processing. It could be DPUs or IPUs or XPUs or whatever you want to call the network processing offload boards that are going on. It could also be technologies like CXL that make memory sharing and memory pooling more popular. There's a lot of companies here talking about disaggregation. The bottom line here, though, in my mind, is not that we're going to go to more specialized systems, but just that we're going to go to a more flexible system with more types of processors. I still don't think that we're going to have sort of specialized vertically integrated systems so much as we are going to have a pool of more varied resources that are going to be applied to enterprise problems. And that's what we see with VMware. They're going to be enabling all of these products to be dynamically brought together That's what we're seeing from CXL. That's what we're seeing from disaggregation. And I guess, Justin, how does storage fit into that kind of next gen data center picture?
Well, I think part of the challenge is if you're trying to deploy infrastructure that can be general purpose, but for a broader set of use cases, right? We're talking about how do we expand the use cases that my general purpose infrastructure can do to encompass these new and sophisticated workloads or these new accelerators. And I think, on the accelerator point, just as sort of one counterpoint to that, we're seeing more accelerators partly because of that pressure on power. I remember several years ago, my phone got a special chip just to do the camera stuff. And that was less about, that they couldn't do it on the CPU of the phone, but it was about, well, now we can do it at an eighth of the power. So we talk about these accelerators using a lot of power, but counterintuitively, they actually do that workload much more efficiently from a power standpoint than a general purpose. So how do we build a highly composable system with all of these different, either accelerators incorporated into CPUs, discrete devices? How do we compose all that together? And the thing that's going to tie all of that stuff together is the data that they have to consume. And so if we have all of these, sources of data, it really is mandatory that we consolidate this into a single place so that all of these different resources, all of these different parts of this future composable infrastructure can leverage and take advantage of that. Because the last thing you want to do is create 100 different silos of this data, and then that not only becomes a huge waste from a capacity standpoint, but it also then can become a compliance nightmare or a data governance nightmare.
So the hardware is always way ahead of the software. So let's put this into some context, because I want to dig into, Justin, your comment about your overall data compliance conversation. But before that, let's talk about the practical, because some of the stuff that we're talking about is way in the future. And if we look at data center refresh cycles of roughly a 5-year rolling calendar or refresh rate, CXL is on the far end of that. I probably won't buy my first CXL switch for another 4 to 5 years. Then, as we think about the software control plane, whereas companies like VMware and enabling the disaggregation and the virtualization of that, and then the x86 compute of where we're at today. So we know we have plenty of x86 compute. We have a glut of CPUs. We have this management capability in all of the data center control planes platforms, from Kubernetes to VMware vSphere to Nutanix, Windows, etc. What we need to probably focus on, I think, Justin, is this data compliance story, because we're going to use this generalized compute to store all kinds of data. In an ideal world, from my control plane, I'd like to be able to take my ECC data out of SAP, so my transaction data, have that in the same storage system as my AI inference capability, have my general purpose compute inference off of that data, and then my business owners can make decisions. We've seen this happen in the enterprise yet. We didn't call it AI, but SAP HANA is this promise that I can have this super fast in-memory database, this super fast local storage, and now I can make business decisions off of that. And I see AI as an evolution of that overall data center design and capability.
Yeah, and on that, I think it's really important to realize that AI is a special application in that it's going to likely demand, or at least it's going to benefit from lots of data sharing internally. It's going to benefit from the availability to sort of feed it from all sorts of different data sets. And that's actually a big driver in my mind toward using more of a general purpose architecture for AI processing. I mean, we're not talking about retraining a massive large language model. We're talking about basically transfer learning or integrating training from an SAP or a data lake or something like that, it's a benefit, but it's also a concern in terms of all this kind of data sharing. And I think that AI is going to demand.
I think it just, when you were talking, Keith, I think one of the most important things to think about is just simple data governance. And do enterprises, and I would love to hear Justin's perspective on this, do enterprises really have a good handle on where their data is, what's actually in their data stores that would be valuable for AI, and do they have a strategy for the sharing that Stephen's talking about? Justin, what do you think?
I think that the maturity of data governance between the two extremes is an enormous gulf. There are some companies that I think have a very good handle on it, especially companies in highly regulated industries. Sort of by necessity, they have to invest a lot of time, energy, and attention into that kind of aspect. But then on the complete other end of the scale, there are probably very large companies that don't have a strong data governance strategy and practice. And I think sort of one of the things that's exacerbated that problem over the last decade is that our data is in so many more places right now. We have all of this data that might be sitting in the cloud. I can't even count how many times one of those security companies said we found a bucket in this cloud open to the world with all of this sensitive data. We have a lot more data at the edge. We're talking about edge processing and edge computing. Well, that's just another place to have data. And if we look at, when I was in enterprise IT on the customer side, more than 15 years ago, I had all of my data in like 2 data centers. That was all I had to worry about. And now the breadth of where all this data lives is so much more daunting that it becomes a huge challenge. And there's entire there's entire practices, best practices, and learnings that have developed around this, but I wouldn't say it's very consistently applied. And that's a real challenge because, as we've seen, when we're talking about training AI models, the provenance of that data is enormously important. And depending on how certain things go, whether they be in laws getting passed or in court cases getting resolved, the provenance of the data that you train on could be a huge liability for companies in the future.
So let's talk about what I call data infrastructure. This ability to build a platform, a data platform that can be used across data scientists, your existing infrastructure, servicing other applications. I think of the ability to set up workflows, the ability to containerize results. AI is a different workflow than application development. I can't do A/B testing throughout the day to say, hey, did the training I did a couple hours ago, can I tweak the parameters and get different inference results in 5 minutes? This is a iterative process that takes days or weeks. I need the data infrastructure that supports my data scientists evolving their applications and their overall language models.
Well, one of the things that we've been working very hard on is how do we build that sort of storage infrastructure, that data platform that data pipelines can use, the data scientists can use, but that most of the rest of an IT organization can use. And so it's extremely important as we think about how do we handle these data governance, but also these data pipelines and all this stuff going into the future. How do we address that in a way, coming back to sort of our original point, that it's not so disruptive to everything that we do? And so part of our focus has been on how do we address the AI workloads? How do we address the analytics workloads? How do we address the general purpose file workloads? How do we address the massive object scale workloads? And all of these things, if you end up building bespoke infrastructures for each of them, IT is being asked to do more with less, but also being asked to do way more. AI is just one of those things that they're being asked to do way more of. And so our focus has been on how do we design platforms that make all of that as easy as possible by having a very small number of very flexible and scalable platforms.
When you look at all of this and you think about all of the coming technology changes that are happening in the data center, Justin, one question that I have for you for Pure Storage is, what is the storage industry innovating to deliver the core capabilities that enterprise will need? And what is Pure Storage's strategy for this space to make this daunting task that we've been talking about as easy as possible for the customer base? Can you talk a little bit about that?
Well, I think part of our strategy from the very beginning has been to build systems that shed as much of the legacy complexity as possible. And so, Pure having I would say luxury, but really it's a lot of work of being an all flash company. Is that we didn't have to reinvent a lot of things from the legacy space that are really things that complicate infrastructure. And so what our thought process is that if we can focus on a very particular kind of underlying infrastructure and do that very well, then that lets us build platforms that are simpler to use for a customer, and whether that's a data scientist or somebody in the IT organization. And then at the same time, offer tremendous capability that can respond to these new workloads and these new requirements as they come along. So, being able to offer a platform that does high performance file for AI workloads, but at the same time being able to do object storage for large archives, that's enormously valuable to customers. And so the idea of being a highly flexible, customer centric storage and data platform, although I know, Stephen, you comment often when the difference between storage and data. So we'll acknowledge that here. But the idea being that we really want to build platforms that are as common and as flexible as possible, so that people can really consume those for whatever kind of infrastructure needs they are, whether that's AI or whether that's general purpose IT.
So, Justin, we can't let you get away from this. Gestalt and a bunch of us have brands that we got to challenge you on some stuff.
All right, go for it.
I have to challenge you. We talked about power early on. Mm-hmm. And when I think about storage arrays, I don't think about savings on power. Like that hasn't been one of the traditional challenges. Am I just compounding my challenges? I mean, I can just put a bunch of NVMe drives in a local box with some NVIDIA graphics cards, and now my power requirements have just diminished. Is that a way to save on power than buying a pure storage array?
Well, I'm so glad you asked that question. I think actually we just this week, I'm not sure when this podcast is going up, but in the very, very near recent time, we've published our ESG report for all of our fiscal year 23. And that includes a lot of information about how we do use significantly less power. And I've been on a lot of different venues talking about our commitment to better science and how we do things differently, how our direct to flash management is unique, and the power savings that brings are significant. So even if you took a bunch of NVMe drives and plugged those into locally attached in your GPU servers, well, first of all, now you're going to have to manage where all that data lives, move all that data around, make sure that data is in the right place. But moreover, all of that is going to be stored potentially less efficiently. You're going to have more copies of it in different places. But lastly, on a per byte basis, the power utilization is going to be significantly worse than what you can see with a centralized system based around something like direct flash, which is what we deliver.
Yeah, and I think one of the core themes of this conversation has been, how do we take our generalized compute, our generalized infrastructure, spread that across, as folks like VMware, Nutanix, and Microsoft improve the ability to compose hardware, I can have GPUs on one side of the data center and my storage on another side of the data center, and I can assign that directly. Matter of fact, NVIDIA, you can assign the storage directly to cards. So the ability to manage and use my data center as efficiently as possible really does give me the most flexibility. I like the answer.
Yeah, and at the same time, remember, we're talking about how the pressure that these high power accelerators are putting on power infrastructure. If you can address power in one area of your data center and make that lower, you can then do more elsewhere. So if your data center is constrained by power and you want to build an AI infrastructure that can go really fast, you want as much of that AI infrastructure as you can. So if you can essentially use less over here and more over here, overall, your entire workflow is going to go even faster.
So before we wrap up here, what I'd like to do is sort of have us summarize what we thought of this conversation and where we think this is going. And getting back to the premise that AI infrastructure is disruptive to enterprise IT. I think we can see that it is disruptive, but in what ways do you think it's going to be most disruptive, and what's the best way to address that, Allyson?
To be honest with you, I think that everybody knew that something was going to be completely changing in terms of enterprise IT when we first saw ChatGPT last fall. Um, I think that throughout the conversation, what I took away is the logic conversation and what we use to actually process this gets a lot of attention, but AI is about data. And so storage innovation needs to come to the forefront to enable enterprise to take advantage of this technology. I was really excited about what we talked about today in terms of core capabilities, but I'm still on the fence of how many enterprises will build out AI infrastructure or rely on the cloud as their secret sauce for getting this done. I think we're going to see that in the next couple of years to see how this pans out. But I'm excited.
Yeah, and then for me, it's all about the requirements. What is it that you're trying to do? A16Z did a really great podcast series on whether or not you should even have on premises AI, if you should own the capability, at least for the learning part. $10 million for a large language model, not everyone needs to do that. So, where do you need to actually deliver value to the business? What's the gap between what you have in your data center and what's a reasonable gap to close yourself within your own capabilities versus outsourcing that to someone who is already doing AI at scale?
Yeah, and I think that that's the really interesting thing here, because we called our other podcast Utilizing Tech because we wanted to basically make it about the practical application. And it's easy to sort of throw stones and say, oh, vendors trying to sell, whatever. But the truth is that products are very responsive to customer needs, because frankly, if it's not something the customer needs, it's not going to sell. And I think that that's one area where folks from the product side can be very helpful in informing the discussion, because basically, customers are either going to be buying or not buying what you're selling. And frankly, I don't think that customers are going to be buying giant special purpose AI infrastructure on the whole. I think they're going to be buying something that enhances their current infrastructure. Is that what you're seeing, Justin?
Yeah, I think, touching on the premise again, I think AI infrastructure can be very disruptive to enterprise IT, but it doesn't have to be. There are ways that the industry is going to coalesce around where we're going to extend the capabilities of general purpose infrastructure in order to be able to handle those things, right? Not every customer is going to build a large language model with trillions of parameters from scratch. And so in the future, what we're probably going to see is, just like in the very, very old days, you might have had a mainframe to do one particular application, or you might have had a very, specialized database server to do something. And now on the whole, all of those things are running on generalized infrastructure. I think AI is going to have to make that same transition to be widely adopted in the enterprise. Because you're right, Stephen, not everybody is going to deploy a supercomputer in their enterprise. It's just sort of completely contrary to how most enterprises want to work. And so while there's a lot of FOMO right now about AI, the truth is that I think in the next couple of years, what we're going to see is this is going to move a lot out of the experimentation and science project and HPC space, and you're just going to see AI become part and parcel of more and more core applications, core data workflows, and become even more critical to most enterprises.
Yeah, I think we can definitely agree that AI is going to become more critical to enterprises and that they're going to have to figure out an approach to it. So thank you so much for this conversation, all of you. This has been really, really enlightening and interesting. Before we go, though, where can we connect with you and continue this conversation? Justin, where can we learn more about what Pure is doing in AI?
Well, for Pure and for Pure Storage and our AI capabilities, you can check out purestorage.com/AI. We've also got a lot of AI related content on our blog. And for me personally, you can find me on the platform formerly known as Twitter at Justin Emerson, or on LinkedIn with the same. And lastly, the ESG report that I mentioned, you can find that at purestorage.com/ESG. And Stephen, I promise it's more than just the E.
Thanks so much for the conversation, Stephen. This was a really great one. If folks want to follow me, I've been talking about AI as well as the infrastructure that will power it on my platform, www.thetecharena.net. And you can find me online on all the usual places, on LinkedIn at Allyson Klein, or on Twitter and other places at Tech Allyson.
All right. And if you want to find me, I'm on the X Twitter site, X. See what I did there, Stephen? At CTO Advisor, the website where you can find the more longer thought pieces, thectoadvisor.com/blog to get straight to the writings.
And as for me, you'll find me here on the On-Premise IT podcast. You'll also find me on Utilizing Tech. We're focusing on edge computing this season, but like I said, we did 3 seasons on AI. So if you go to utilizingtech.com, you can find those, as well as on our weekly Gestalt IT news rundown. So thank you very much for joining us today. If you enjoyed this discussion, please do give us a subscription. We would love to have you do that. And also give us a rating, review, or a comment. We'd love to hear what you think of on-premise IT. This podcast was brought to you by Pure Storage, as well as GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks for listening, and we will see you next week.